The broadcast is now starting. All attendees are in listen-only mode.
Good evening, everyone. Good morning. I welcome you all. It's been a great pleasure to see you again. So we have, I guess, all the people joined in. So just four or five people who are not joined in. So we have Azhar, Kamesh, Karthik, Kura, Manjunath, Raj, Ramakrishnan, Rangareddy, Sai, Subhajit, Vankat. Hi to everyone. All right, so we'll just continue with our conversation further, and today we'll discuss the practical side of the elastic load balancer. To summarize what a load balancer is responsible to load balance the traffic across different instances. These instances can be spread across multiple availability zones. Apart from that, the load balancer also performs a health check to ensure that all the instances in your architecture are running fine and they are supposed to cater to the user's requirement, which means that they can process the user's request efficiently. So these are the common, I would say, advantages or the functionalities of the load balancer. What I'll just do is right now is I just launch two different instances in different availability zones, and I would be reporting these instances towards the load balancer that we are just going to create right now. Okay, just bear with me for 1 or 2 minutes. I'm just going to launch two different instances real quick, and these instances will also help us to perform the practical of our auto scaling. Okay, because once we cover the elastic load balancer, thereafter we'll cover the auto scaling. Okay, so just give me one moment over here. I'm just creating a new security group, I guess. Okay, that's fine. So I've launched a duplicate instance in a separate availability zone right now. All right. So our two instances have been launched, and these two instances work in the confinement within the region of Northern California, and these are in the two separate availability zones. One is in 1B and another one is in 1C. Now let's go ahead and configure our load balancer. So you can track or locate the load balancer on this EC2 dashboard just on the left side, where it says load balancing. Right now, you get one load balancer free that can be up and running for the entire 1 year under your free tier account. So don't hesitate if you have to create one load balancer. It's pretty fine. You can run 750 hours of load balancer for each month, and this can happen for the entire 12 months of your free tier account. So once I go to this load balancer dashboard, I'll just go ahead and click on create load balancer. Now, first thing first, I have to define my load balancer, and this is the basic configuration that we have to go through. Right now, we have to define or assign a name to this load balancer. So let us name it as test ELB. That stands for test elastic load balancer. And you have to create the load balancer inside the VPC. Now you might be wondering why on the earth I'm saying the VPC, because once you launch your instance, you have to choose a VPC. Now in the load balancer, I have to do the same thing again. Why we need to define our VPC in almost all the configurations of the resources inside our Amazon Web Services. So the thing is, VPC means that it's your own network. Now we'll cover the VPC in detail once we cover the networking components. But I just want to give you an FYI or highlight that why on the earth I'm selecting the VPC. So I'm just open the notepad just to make a drawing to make it more understandable. Right. Let's suppose that this is your Amazon Web Services cloud. Now, anything that you launch in the Amazon Web Services cloud would be launched in your VPC, Virtual Private Cloud. Virtual Private Cloud means that it's your own virtual data center that's being launched on the Amazon Web Services cloud, right? That you mean by this VPC or the Virtual Private Cloud. Now, how you create or structure your entire network? So you create a VPC. What you do is that you assign a range to the VPC. For example, the range of this entire VPC is, let's suppose, 10.0.0.0/16. This is a CIDR range. Right. Once you carve out a VPC and you manage to assign a CIDR, or I would say an IP address range to it, then you carve out two different subnets or multiple subnets. You can have multiple subnets depending upon how much your IP address range can allow. So this IP address range, just an FYI, can allow me to create 256 subnets within this entire VPC. 256 subnets. But I will just create two subnets because it is more than sufficient for me right now. So what I will do is I create two different subnets. Now this is my subnet A. And whenever you create any subnet, you have to associate that subnet to one of the availability zones within which you are creating your VPC. So let's suppose this subnet A associated to availability zone A, and this is subnet B associated to availability zone B. So almost all the resources will lie under the confinement of a VPC. Now you will have all your instances, whether it's web instances or whether they are database instances, whatever they can be. Whatever they can be. So you create, so let's suppose this is not a database instance, this is a web instance. All these web instances are being launched within your subnets. For example, for this subnet, I have an IP address range, for example, let's suppose 10.0.1.0/24. And for this subnet, the range would be 10.0.2.0/24. Right. Now, you have structured or created your network in such a way that these are your web instances inside the subnets. Now what you will do is that you will just go ahead and place a load balancer over here at the top. That's called ELB, or the elastic load balancer. What will happen in an ideal situation is that, let's suppose that this is a user. Let me just hang on one second. Okay. Hang on one second, please. Okay. So let's suppose that this is a user over here. And in an ideal situation, he will send the traffic to the load balancer. And the load balancer will forward this traffic to different instances in different availability zones of the subnets in the same VPC or the same region. If I'm saying VPC, I'm pointing towards the region. If I'm saying subnets, I'm pointing towards the availability zone. Right? So what I want to emphasize over here is that all your resources, whether it's an elastic load balancer or the instances, will always be up and running in the confinement of a VPC. Now over here we have the load balancer that's included in the VPC, and it is serving different subnets, different availability zones, and it's forwarding the traffic to all these instances. Therefore, it is mandatory for me that once I define my load balancer, all right, so once I define my elastic load balancer and the instances, they should be in the same VPC, right? Because if a load balancer is in a separate cloud, then it cannot serve the traffic for it. Okay, so I have to define my load balancer's VPC so that I can very well have the understanding that, okay, all these three resources, the load balancer and my instance in separate availability zones, are residing in the same VPC, and it gives me an overview that, okay, how I'm going to design my network, right? So if I just go back to our this management console, let me just open my services, EC2 over here real quick. So these instances right now that are up and running, that are launched right now in front of you, these are the part of this VPC ID, VPC 177E672. Now this is the default VPC of my Northern California region, VPC 177E672. Now I have to choose the same VPC. Now this is the range of this VPC. Let me show you that. If I just go back to the AWS Management Console and go to VPC, it's taking its time. Okay, so right now this is the VPC dashboard from where we create, manage our all VPCs for a particular region. I go to this one VPC right now, and we can see this is my VPC with this range 172.31.0.0/16, right? So this is the same range that is showing up over here. Now my instances are launched in the same range, which means I'm ensuring that my load balancer is being launched in the same VPC where my instances are being up and running. All right? So I guess you got the idea of what I'm trying to deliver right now. That if you are structuring or you're just architecting your network, these things we have to keep in mind. Okay. Now it says create an internal load balancer. By default, all the load balancers that you create, they are assumed as an internet facing. Okay, if I check mark this option, it becomes internal load balancer. In that case, it will never receive the traffic from the internet, and it will purely, I would say, carry out or take care of the internal traffic within the VPC. Okay, but I just want this load balancer to work and get the traffic from the internet. So therefore, I will just uncheck this option. All right. I guess we have a question right now. Tony, your question is it impossible to extend VPC over multiple regions? Yes, Tony. It is impossible to extend your VPC over multiple regions, but yes, you can adjoin different VPCs in different regions using a concept called VPC peering. I'll discuss that. No, okay, VPC peering will not work over there. I'm sorry about that. But you can route the traffic between different VPCs in different regions. That you can do. You can somehow logically, I would say, extend or connect your VPCs scattered in different regions. Okay, so as of now, it is impossible that you can extend the same VPC over multiple regions, but you can have some kind of tools or features that you can apply to connect all the VPCs in different regions. Once we cover the VPC, we'll discuss all these things in detail. All right. Now, okay, where were we? So we discussed that this is my internet-facing load balancer. Internet-facing means that it is intended to receive the traffic from the internet. Therefore, I'll just go ahead and keep this option as unchecked. Now comes the main thing: enable advanced VPC configuration. Now, I chose a VPC. Now I have to go into the advanced details of the VPC and choose the subnets. I checkmark this option. Once I checkmark this option, I scroll down, and it gives me a message. Please select at least 2 subnets in different availability zones to provide higher availability for your load balancer. Right? Now, if you can recall, I created a diagram where the load balancer will serve the traffic for different instances that are spent or that are running in different availability zones associated with different AZs. Now, this subnet with this range, okay, is associated with my availability zone US West 1 Bay, and this subnet with this range is associated with my availability zone US West 1 Say. Right? So if I select both these subnets or availability zones, which means that now they are bound to receive the traffic from the elastic load balancer that I'm just going to create right now. Okay, so I'm selecting the subnets for each availability zones to get the high availability so that I wish to with the traffic to be routed by our load balancer. If I uncheck any one of these options, for example, I just took out 1 bay. So in that case, this load balancer that I'm just going to create right now, it will never ever send the traffic to the 1 bay. Okay, so whichever subnets or the associated availability zones you want to receive the traffic from the load balancer, you have to select from here. All right. Now, here comes the last piece of configuration. That is listener configuration. What is that? Listener configuration is a process of listening to the request. So this works in such a way. Let's suppose that this is your user. Right. He is sending the traffic to the load balancer, and the load balancer is forwarding the traffic to different instances running in different availability zones or subnets. It all depends how you have structured your network or you have architected this entire thing. Now, the traffic that flows from the user towards the load balancer, in this direction. This is called the front-end traffic. This is called the front-end traffic. And the traffic that flows from the load balancer towards your instances, or which means that the same traffic, front-end traffic is being moved further from the load balancer towards your instances. It's called the backend. It's called the backend. So I re-emphasize, any traffic that flows from the user towards the load balancer is called the front-end traffic. Any traffic that flows from the load balancer towards the instances is called the backend traffic. Now, depending upon this, we configure the listener configuration. On the left side over here, let me show you that. On the left side, this thing, which defines my load balancer protocol endpoints, it defines my front-end traffic. Anything that flows from the back end, it is defined by the instance protocol endpoint. This defines my backend traffic. So through the listening configuration, what's the listening configuration? It's a process of listening to the request. What kind of traffic I want to entertain at the front end? What kind of traffic I want to get forwarded to at the back end? For example, let's suppose by default it will allow HTTP traffic. Now, as we discussed yesterday, Elastic Load Balancer supports 4 different types of traffic: HTTP, HTTPS, TCP, and SSL. So by default, it will allow HTTP over port 80 both at the front end and the back end level. Sometimes, due to my application's requirement, I may forward it from HTTP 80 at the front end and HTTPS over port 443 at the back end. Okay, or I can allow HTTPS both at the front end and at the back end. It all depends upon what's my requirement, how I want to forward the traffic. Right. So what I want to emphasize over here is that you can define different kind of protocols or same protocols both at the front end and the back end configuration by defining the load balancer protocol endpoint, instance protocol endpoint. But yes, one thing you have to keep in mind: if you define the HTTPS at either side or both the sides of this configuration, you have to upload an SSL certificate for the authentication. I don't have the SSL certificate right now. There is a service on the AWS Member Console that's called the Certificate Manager, from where you can buy the SSL certificates. Okay. Now, just for this example, I'll choose HTTP or port 80 both at the front end and the back end. This is my step 1 to define my load balancer. To summarize, I define the load balancer, I choose the VPC, I will keep it as internet-facing load balancer, I enable the advanced VPC configuration to select both the subnets and the associated availability zones, and I define my listener configuration. Any questions, any doubts regarding this step 1? I'm just pausing for a few seconds. I guess we have a question right now. Kuram, your question is when we need the TCP traffic. Kuram, we need the TCP traffic just in case we want to allow any kind of traffic apart from HTTP and HTTPS. Right. For example, we need to allow the RDP traffic. So I would choose TCP, and I define port 3389 because RDP it communicates over TCP port 3389. For example, I want to allow SSH. I would choose TCP or port 22. I want to allow MySQL traffic. I will allow TCP or port 3306. Okay, so I will choose a TCP in the cases if I want to define some custom-based TCP traffic based upon what kind of application I'm running on my web instances. All right. Okay. So now let's go ahead and click on Next Assign Security Groups. Now you have to assign the security groups to the load balancer. Reason being because the load balancer it's getting the traffic from the internet. So it's a big concern because you have to facilitate the security for your load balancer. So what I'll do is I'll create a new security group. I'll just name it as ELB security group right now. And let's define the description. Right. Now, for this example, I will allow HTTP traffic over port 80 from all the sources. Okay. Next, I click on Configure Security Settings. Now, I need to skip the step. You will configure the step if you are allowing HTTPS traffic. In that case, you have to upload the SSL certificate. But as of now, we don't need to configure the step 3. I can skip the step and move further. Next, I configure the health check. Now, in health check, it's quite important. Health check, as we have discussed, a load balancer performs a health check for instances. Okay, so let me just re-emphasize and discuss that concept again because it's very important. What happens is that let's suppose that this is your elastic load balancer, ELB, right? What it does is that it pings or it sends a health check message, a TCP keep alive message to your instance. By default, it does that by using the HTTP traffic over port 80. It sends the health check message, and since it's a TCP traffic, it's quite obvious that it will wait for the acknowledgement. It says, hey instance, are you fine? Are you up and running? Can I send the traffic to you? If this instance say, yes, I'm fine, send the traffic to me, the load balancer will get to know, okay, it's fine, so let me forward the traffic to it. Let's suppose that this instance is now down. It is shut down, it is terminated, something went wrong, and it is not in a situation to receive any kind of traffic from the outside. Consequently, well, now what will happen? The load balancer will again send the traffic to it, say, hey instance, are you fine now? Now, this instance is shut down. It will never ever respond to the load balancer's health check. Now what happens in a layman example? Let's suppose that whenever you give a phone call to any person and you say, hello, are you there? Hello, are you there? After a few seconds, if no one responds at the back end, you disconnect the call and try again. It is the same thing over here. The load balancer will say, hey instance, are you there? Are you fine? Can I send the traffic to you? If this instance is shut down, it is not in a state to respond to the load balancer's health check. The load balancer will sense that, okay, there's something wrong, and it will stop sending the traffic to it. Now, after a few seconds, this instance came back up and it is up and running now. So the load balancer will say, okay instance, now just tell me, are you up and running? Instance say, yes, I am now. Now then load balancer will start sending traffic to it. This is how then an elastic load balancer works. This is how it comes into the action. Right. Now, this is a crux or the essence of this entire configuration. We'll discuss that right now. Okay, this will be a question. Khurram, your question is, what kind of health check ELB performs? Is it checking some process on target machines? No, Khurram. It will not check any of the processes. It pings the default web page of your website. Right? On the top, you have to choose the ping protocol endpoint, which means what kind of traffic you want to send to send the health check traffic towards the instances. The ping path means the default web page of your website. So an elastic load balancer sends the HTTP traffic or port 80, that's the health check traffic, over the default web page. It can be either a / index or HTML, or it's a /. In our example, I use / because based upon our application that I have this hosted on my instances, a / would act as a default web page. Okay. Kamesh is saying how the load balancer comes to know when it is up. Kamesh will discuss that. Yeah, so Kamesh will discuss that. How it will sense that if it's up and running. Khurram is saying, what if it's not a web server? For example, it's a HTTP name node. Khurram, I'm not sure what an HTTP name node is, but any kind of server that you define, you define a default web page. Okay. Now, one thing you have to keep in mind that this elastic load balancer never ever works on the database instances. Except for database instances, any kind of web server, any kind of HTML server, HTTP or HTTPS server will receive the traffic from the load balancer. So, but the question is there any relation with the backend traffic configuration? So, but it all depends upon that. What's the purpose of the load balancer? Okay, the backend traffic configuration, for that you have to define your internal load balancer. Okay, Khurram, you're saying answer not clear yet. Khurram, you're saying what happened if the target EC2 is not a web server? For example, it's an HTTP name node or Hadoop name node. Now, Khurram, I'm not sure what exactly Hadoop name node is, but if it's a Hadoop cluster, right? It's a collaboration of some instances of the servers. So, Khurram, I'm not sure whether it will work on the Hadoop name node or not. I'm quite sure. I'm not sure about it because I don't know that how it's configured, whether you define the default web pages for those nodes or not. I'm not sure about it. If in the Hadoop name node you define the default web page, then you can very well specify the default web page over here. Okay, if the Hadoop name node does not, I would say, support any default web page creation, then the load balancer will never work on that. Okay. So, Vidit, your question is: suppose in the backend configuration we have open HTTPS and we are using HTTP. Will it work? Of course, it will work. Subhajit, it will work. The thing is, this traffic that we are configuring right now, this is not the actual traffic we are referring to. So, I just want to make clear that we don't get confused between the real traffic and the health check traffic. Both are different. This thing right now, it's a health check traffic, not a data traffic. So over here, I just want to make sure that we're not getting confused over here. It's not a data traffic. This is purely a health check traffic. That's it. It's not a data traffic. It's not the actual user's data request. Okay. So now, what I'm saying is that, okay, my elastic load balancer, give me 1 second over here. About that. So what I'm saying over here is that my elastic load balancer needs to perform the health check. What kind of traffic it would be sending just to perform the health check? By default, you should always choose HTTP. If it's an internal load balancer, you may choose HTTPS depending upon your requirement, but in most of the cases, it is an HTTP traffic because it is just a health check traffic. It does not carry any packets for your data. Okay. So I define the ping protocol port and the path. Now comes the real action where I have to configure the advanced details. What are the advanced details, by the way? Advanced details means that how frequently you will perform the health checks. Okay. So I guess if I explain with the example by using a diagram, it would be much more clear instead of using the slides on the theory. So let's do one thing. Let's take an example again. All right. So let's suppose that this is my load balancer, and this is an instance. In an ideal situation, a load balancer sends the health check message to the instance. Now, in the TCP traffic, there's always an acknowledgement. You might have heard about TCP handshake. Now, what happens is that the load balancer sends a health check message, and it expects a response. Right. Now, once a load balancer sends a health check message, and within 5 seconds, if this load balancer doesn't get the acknowledgement that is being timed out, it says response timeout 5 seconds, which means the load balancer sends a health check message to the instance, waits up to 5 seconds to get the response. If it doesn't get the response, this message is timed out. Right? So a load balancer sends a health check message to the instance, waits patiently for 5 seconds. If it does not get a response or acknowledgement, it times out that message because it's not a successful health check. So we have discussed our response timeout. Next is called the interval, that is of 30 seconds. It's a time gap between 2 consecutive health checks. Now this is my first health check. After 30 seconds, after a gap of 30 seconds, there will be a second health check. After a gap of another 30 seconds, there will be a third health check. So this process will continue. So interval means it's a time gap between each and every consecutive or 2 consecutive health checks, which means by default a load balancer is bound to send the health check message to all your instances after a gap of each 30 seconds. Right. Now you can increase the response timeout or decrease it. You can increase the time interval or decrease it depending upon your application's requirement. But these are the default values. You can manipulate or modify them. It's up to you. Unhealthy threshold. What's that? Unhealthy threshold means that after how many consecutive health checks in a row, an instance should be declared as unhealthy. For example, for this first and second instance, there's no response that it got from the instance, which means for 2 consecutive health checks in a row, because this instance over here was down, it was down. For 2 consecutive health checks, it didn't respond. It says, okay, instance, for 2 consecutive health checks, you did not respond to my health check query. I declare you as unhealthy. And now you will not receive the traffic from me. For any 2 consecutive health checks in a row, if a load balancer does not receive any acknowledgement to its health check message, it says, load balancer, I think there's something wrong with you. You are unhealthy from my perspective. I will not send you even a bit of data to you now because you're unhealthy. That's called the unhealthy threshold. Now comes the healthy threshold, which means 10. This means that, let's suppose till this point of time, I'm just drawing a border right now. It was healthy. Now from 3, 4, 5, 6, 7, 8, 9, or I would say from 3 to, let's suppose, next, for 3 to next to 12th. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or 12th or 13th health check. For continuously for these many thresholds, this instance, which was down before, it has come back up. For 10 consecutive health checks, if the instance that was down before, so this instance over here was down before, it was unhealthy. Now for 10 consecutive health checks, it is giving a good signal. It is responding. So the load balancer will say, okay, instance, you're up and running now. You are healthy. Previously, you were not responding to my health check, but now for 10 consecutive health checks, I can see that you're acknowledging to the health check messages sent by me. I treat you as healthy, and now this is your traffic. I'm forwarding the user's traffic to you. All right. So these are the advanced details that we have to configure. These are the default values. Depending upon your application's requirement, you can modify them. Any questions so far regarding step 4? I'm pausing for a few seconds. All right, so I guess we have a question right now. No questions, Kamesh? Guys, any of the questions you have? Kuram, Subhajit, Kamesh, Tony, Manjunath, Karthik, any questions you guys have? Seva, Subhash, Venkat. Seva, your question is, if there are multiple instances, how it will work? Seva, even if you have multiple instances, all these configuration will apply same on all these instances. Ramakrishna, your question is, can you give an example of a ping path? All right, sure. So Ramakrishna, the thing is that it's a good question that you asked, that ping path. See, right now it's nothing about internal or external, right? Ping path means that you are giving a path for the traffic to hit and get an acknowledgement, right? Because let's suppose that this is a web server, right? This is a web server. Upon this web server, I just create a web page called index.html. Index.html. Now, I'm instructing the load balancer that perform the health check. Now, the load balancer is clueless. Okay, I'll perform the health check, but could you please let me know where I have to reach? See, the thing is, in a very layman example, if I want to say that you have to reach your friend's house, now you haven't seen his home, you will say, okay, I will reach my friend's house, but what? Could you please tell me where I have to reach? What's the destination? What is this home's address? I'm giving an address to the load balancer to hit. Okay, load balancer, hit this default web page index.html, so that from here you can get the acknowledgement. So it's a ping path I'm giving you. That okay. See, what happens is whenever I ping any website, ping google.com, ping facebook.com, what I'm trying to say, I'm trying to ping their pages. So I'm giving a default web page to load balancer that you have to ping a default web page of my web server. Shiva, your question is, say it will send data to all instances at the same time, or will send the data one instance, and it will stay. It will wait till it's unhealthy. Okay, Shiva, the aspect question is saying that it sends the traffic to all the instances at one time. See, it sends the traffic and performs the health check consecutively, right? Because that means that it does that side by side. Besides sending the traffic, it also performs the health check. Now, it load balances the traffic, as we discussed before. For example, let's suppose that, let me just remove this drawing. Let's suppose that this is my load balancer, and these are the two instances reporting to it. If any user sends the traffic to the load balancer, it will send the first request to this load balancer, second to this one, third to this one, fourth to this one, fifth to this one, sixth to this one. So it load balances the traffic. So one data stream is sent to one instance, second to another one, third to first one, fourth to second one. This is how it load balances the traffic. Now, this is about load balancing the user's traffic. I'm talking about the user's traffic, but now we are talking about the health check traffic. So over here we have to just make one thing clear, that user's traffic, the data traffic, users or data traffic, and the health check traffic both are different. Apart from handling the user's traffic as a default behavior, it will perform the health check based upon the values you have defined. Okay. It will never mix a user traffic with a health check traffic. While sending the user's traffic, it will also perform the health check. And if any one of the instances does not show any positive response, it will stop sending the traffic to it. So both these two operations work hand in hand. All right. So Ramakrishna, this okay. You answered the question, and Shiva, this answered your question. Totally, your question is, if the server ID is up or down, is the only logic behind balancing. Is there any way to balance load based upon how many requests a server is handling, or it is out of scope of ELB? It is out of scope of ELB, Tony, because the load balancer never ever works on the application level. Okay, so how many requests a server should handle, that is not being catered by the load balancer. But yes, one thing you can do is you can enable the CloudWatch alarms, and you can have some kind of actions initiated. So for example, if your server is getting too many web requests, you can spin up more instances, and have the load balancer to send the traffic to other instances, that you can do. Okay. So Ramakrishnan question is, as default of all the servers should be have index.html to perform the health check, right? It's not mandatory, Ramakrishnan. It can be index.html or it can be just a /, because the applications that I'm running right now, the ping path, the default web page is just a /. So depending upon what kind of default web page you have defined, you have to define over here. Most of the cases it's index.html. Okay. All right. So now what I will do is I go ahead and click on add instances. Now I will just go ahead and add both instances right now. This one. In the down below, it's enable cross-zone load balancing, which means I want to route the traffic across different zones or availability zones, and the connection training we have discussed yesterday, so that it will ensure that all the instances receive the traffic, and if the instances get deregistered, the load balancer keeps on training the traffic or holds the user session for next 300 seconds. It's a number of seconds to allow existing traffic to continue flowing. I can increase or decrease its time value. Next, I click on Add Tags. This is just tagging your resources to help you to organize them or identify them just for the documentation purpose. It is not mandatory, so I'll just go ahead and skip the step. I click on Review and Create. I can review all the options right now and hit on Create. It says your load balancer has been created. Let's wait. Okay, so it says successfully created the load balancer. Load balancer test ELB was successfully created. I click on that. Okay. So this load balancer is taking its own sweet time. We have to wait for a few seconds right now. Let's wait. All right, so okay. Now, this will take some time to show in service right now. We have to wait for a few seconds because it takes around 5 minutes to get these instances registered. If I go to the instance, they're showing out of service. So they should show in service after a few seconds right now. Okay. One important thing that we have to understand over here is whenever you route the user's traffic, you will send the traffic to the DNS name of your elastic load balancer. You will never ever route the traffic towards the load balancer's IP address. First thing first, on this AWS Management Console, there is no provision for you to get to know the IP address of the load balancer. Why? Because it's not necessary. AWS recommends that never ever route the user's traffic to the load balancer's IP address because it is subjected to change after a few seconds, or few hours. You can see over here, because the set of IP addresses associated with the load balancer can change over the time, you should never create an array record with a specific IP address. Now, if I just perform an NS lookup right now on my terminal, NS lookup, and I just copy and paste the DNS name. You can see that these are the two IP addresses associated with my load balancer. After a few hours, it may change. It may change. So this thing you have to keep in mind, that you have to route the user's traffic towards this DNS name of the load balancer. I will discuss in Note 53 how to associate the DNS name with your domain name, like your google.com, facebook.com, whatever website domains you have. All right. Okay, now you can see the status of two instances in service, and you can see this is over here in service. Now I'm copying and pasting this link for you. You can just copy and paste this link on your browser, and you can browse through your this load balancer. I'm just copying and pasting the chat window. You can just try this one out, and if I just try from my side on my browser, I will just go to the website right now. If I refresh this page, it will take me to US West 1B instance. Refresh the page, US West 1C. Refresh the page, US West 1B. After each refresh, a new session is being initiated, and the load balancer routes the traffic to a different instance in a separate availability zone. I refresh the page. So I guess you are also doing right now. So it calculates that, okay, which traffic, how much traffic has been routed to each instance. So guys, you can also browse it and let me know if you're getting the results. I'm just waiting for your response. Let me know if you're getting the results right now. Just try. I'm just pausing for a few seconds. Okay, Kamesh and Shiva they're getting the pages. That's good. Okay, it is changing, Tony. That's great. That's great. Sounds good. Yeah, so it's changing in between. So what I want to show is the default behavior of the load balancer. Right. After each refresh, it will send the user's traffic to a separate instance. Now let's do one thing. Yesterday we discussed stickiness. What is stickiness? I take the user session to a particular instance. Right now, this stickiness is disabled. I hit edit. I click on enable load balancer generate stickiness session, and this just type in 300 seconds. Hit save. Now you guys, if you refresh the page, you will always land to only one instance for the next 5 minutes. You can just try this one out. Right now I am on 1B. I will always remain on 1B. If you are on 1C, you will always remain on 1C. Just see if you refresh the page and see it should not change for you. Just try this one out. Because I have enabled the stickiness. So the first time when you landed to one of the instances, for the next 5 minutes, your sessions will be sticked to the same instance. Yes, Shiva, it will be immediately. It's working for me. So as soon as I enable the stickiness, I'm not getting to 1C right now. Yeah, so it's not changed. It won't change. Yeah, Ramakrishna, it will work because stickiness will come into action as soon as I enable that. And the first time, if I land it to one of the instances, for the next 300 seconds or 5 minutes, my sessions will stick to that instance. All right, this is how it works. All right. So we have discussed stickiness, connection training, instances. All right. And also you can see the CloudWatch monitoring stats of your load balancer, unhealthy host, healthy host, latency, some request. We don't have to go in details about all these things, but you can see the graphical overview of how many requests you're getting. All right. That's it. So this completes our load balancer. So Vijay, you're saying during the configuration that the ELB stickiness can't be configured. No, Subhajit. During the configuration, you didn't get the option. But yes, once you configure that, just after configuring, you get the option. Because load balancer, once configured, it takes around 5 minutes to boot up. So within 5 minutes, you can very well enable stickiness. It just takes a few seconds for you to configure. Okay. So this completes our load balancer. I hope that it's a high-end overview that I was trying to give you. Just try to make it more practical instead of just going through the slides. Any questions, any doubts so far? Anything you want to ask? Because sometime we can just take a small break. Yes, you have a question, Venkat? Yes, one. I'm just waiting for a question. Venkat is saying, can we use one Linux instance and one Windows instance in the ELB? We can do that, but the thing is then we have to define our default web page is same for both instances. Raj, it can be possible. It can be possible, but if we have the same default web pages defined for both instances somehow, then we can do that. Otherwise, in an ideal situation, these instances should be identical in nature. In an ideal situation, because we will not achieve anything if we load balance the traffic between different platforms. We can achieve that. We can do some workarounds, but at the end, we'll not achieve anything because the load balancer always load balances the traffic on identical instances, not on separate platforms. But the thing that you're telling Venkat, we can achieve that, but yes, we have to do some workarounds and all these kind of things. Venkat is saying both instances are out of service, Venkat, because you haven't launched any application and defined the default web pages for those one. That's why. Okay, because I've deployed my web application by defining the / the default web page. That's why it's showing in service. If you have defined your application and the default web page properly, then it takes around 3 to 4 minutes for your instances to show in service. Okay, Raghavendra, your question is, what does the listener do in your load balancer? Raghavendra, the purpose of the listener is to listening to your request. You define that what kind of traffic you want to entertain at the front end and how you want to forward that traffic at the back end. For example, do you want to allow HTTP traffic both at the front end and the back end? Or you want to receive the traffic HTTP at the front end and forward it at the HTTPS at the back end? For example, let's suppose your corporate applications, whenever you access your corporate websites from your home, you open them as HTTP, but after some time or once you access your websites or your Outlook web access, it gets converted to the HTTPS automatically. It's the same thing. Ramakrishnan question is, I was unable to find the assessment on Drive, rather than you can help me to place on Drive, Microsoft, please. I'm not sure, Ramakrishnan, why it's not, because only you are complaining, other people are able to get this thing. I don't have access to the Microsoft Drive. I haven't created any account on that. So I would say that you can change your browser. Just try to access Google Drive on the Google Chrome or Mozilla Firefox. Kamish is saying that we need to have associated web application on each instance. Yeah. Raghavendra, can we help HTTPS to ELB to HTTP on EC2? No, it will not work, Raghavendra. It will not be a right configuration. You can allow HTTP to HTTPS, HTTPS to HTTPS. HTTPS to HTTP will not work. I don't think so. Kuram is saying, we will be covering in this class how the load balancer manages a workload, for example, extend, create one more EC2 machine as per the business need. Of course, Kunal, we'll discuss that. We'll discuss that. We'll discuss the auto scaling just after a break. After the break, once we discuss the auto scaling, we'll discuss how the auto scaling works hand in hand with the load balancer, so that if we extend our architecture as per our business requirement, how the load balancer is supposed to send the traffic to it. We'll discuss that after the break, once we discuss the auto scaling. Majuna is saying TLS to SSL. A TLS to SSL or SSL? Yeah, this will work, Manjunath. This will work. So it all depends upon your application. Whatever combination that you want to go, it all depends upon your application. Okay. Okay, Ramakrishna, I'll just give the drive URL again at the end of the session, so that you can just try again. All right. All right, guys. So let's do one thing. Let's take a break for 15 minutes, 1-5. You guys take a break, have your dinner or lunch, depending upon your time zone. Refresh yourself, because once you come back, we'll go into a very high intensive lab session auto scaling. I bet that you will enjoy that session, because it is a highly technical thing, and it's I would say you will also use the load balancer with that. So it will interest you. You will enjoy that session. So just after, just refresh yourself, just relax within 15 minutes, and once you come back, we'll discuss the auto scaling. All right? It's a break for 15 minutes. Thank you. Welcome back. I guess I'll be right back now. We can start our session. So now we'll discuss the concept of auto-scaling. Auto-scaling is a very important concept or feature to understand. The reason being because auto-scaling will help you to create a highly available and a fault-tolerant application in an automatic manner without any manual intervention. Right. So we'll discuss the auto-scaling concept, and we'll discuss the, I would say, the practical application of that. Right. Just give me 1 second over here. An introduction to auto-scaling. What is an auto-scaling? Auto-scaling means that you can modify your architecture whenever it's required. Right? Auto-scaling is a practical application of a concept called elasticity. Elasticity means that you can anytime increase or decrease the number of instances, or you can grow or shrink your architecture based upon certain thresholds like time of day, demand, or patterns of the incoming traffic. Auto-scaling is a practical application of the elasticity. Now, you have a concept called auto-scaling groups. We'll discuss it further in detail. But what happens is that in auto-scaling, whenever you want to modify your architecture, you group your instances together in the form of auto-scaling groups. For example, you might have grouped your instances based upon their functionalities, their behavior, the kind of services and applications that they're running. You might have a group for a front-end application instances and the group for the back-end. Also, we define policies in auto-scaling. Now, this is quite important. Policies means that how you're gonna grow or shrink your architecture. Policies means that what are the thresholds you want to define. So in the policies, we define the thresholds. We define that how you're gonna build your architecture around the auto-scaling. What kind of things will act as a catalyst and increase the number of instances automatically, or decrease the number of instances on your behalf in an automatic manner. So the policies are the driving force behind this auto-scaling. We'll discuss how to configure the policies from scratch. Right. Now, what are the benefits to get out of the auto-scaling? Because auto-scaling means that you can modify your architecture whenever required. You can grow or shrink your architecture depending upon the time of day, patterns, patterns of incoming traffic, values, thresholds, and so on. But what are the benefits you get out of it? First thing first, it makes your design more fault tolerant, which means that it is less prone to downtime. I would say there's absolutely no downtime. If you have configured your auto-scaling groups and the policies in a proper way, I don't think there's any downtime. It makes your application more highly available, right? It makes your application more highly available. The third point that I want to add is that it always ensures that there's a right capacity of instances to be up and running to support your architecture. The right capacity. What do you mean by that? Let's focus on this diagram. I'll just pick this one. US West, Northern California region. These are the two availability zones, Zone A and Zone B. Now I've structured, or I've just created my architecture in such a way that I have 4 instances running in my Zone A and 4 in Zone B, which means in total I have to have a write capacity of 8 instances to support my infrastructure. 8 instances or 8 number of instances is the right capacity for me, because if we go below that, then my application would not be able to cater to users' requirement. So 8 instances is must. Now something went wrong and your zone A goes down. If the zone A goes down, it's quite obvious that these 4 instances would not be available. Right? What will happen is that the auto scaling, based upon the configuration and the thresholds you define, it will launch 4 more instances in zone B. The duplicate instances, it will launch 4 more duplicate instances in zone B, so that you always have the right capacity of 8 instances to support your architecture. It will do automatically without any manual intervention. You don't have to intervene, you don't have to check anything. Based upon the initial configurations you define, all these operations will be taken care of automatically. So this is the beauty and the power of the auto scaling. We'll see how it will work. Okay. Now let's move further. What are the components of auto scaling? Let's discuss the components first before we can start how the auto scaling works at the back end. First thing first, we have something called groups. What is a group? A group is a logical collection of identical EC2 instances. You create certain groups for you, so that those groups that you create, for example, I suppose you create a web tier group. So this is a group called web tier, and you just have all these web instances. You have another group called application tier, app tier, that will work at the back end to support your web instances. So based upon the functionalities, based upon the set of application services running upon those instances, you group your instances in the form of auto scaling groups. Right? Next thing that is very important for us to understand is called the launch configurations. What are the launch configurations? Why it's a very necessary building block in our auto scaling. Why we need that? See, this launch configuration, it is nothing more than a template. It is just a template. That's it. But even though it's saying it is just a template, it's quite important. Let's suppose this is an entire template document called launch configuration. This template contains the necessary configuration items to build your instance from scratch. For example, let's suppose, what would be your AMI of your instance? What would be the security group, S3? What would be the key pair, KP? What would be, let's suppose, the EBS volume assigned to it? What are the scripts you want to install on the instances? All these things you define as a template called launch configuration. And this template called launch configuration is applied to your groups. Right? Because if I'm saying that your instances will launch automatically, if I'm saying automatically, how on the earth the instance will get its configuration automatically? I have to imply some template. The template that I have to apply on those future instances would be launch configuration. It contains everything, starting from AMI, EBS volumes, security groups, key pairs, scripts, everything that is required to boot your instance. It's recipe. right? So any of the future instances that gets launched automatically, those will be launched in the auto scaling groups, and they will refer to the launch configuration to pull the configurations. I'll show you how to manage or to formulate your launch configurations. Apart from that, we have scaling plan. Anything that we want to apply requires a soundproof plan. If a plan is not good, then your architecture would be a big mess. Scaling plan means I need to define some policy that, okay, how these groups will come into action. So scaling plans more is a kind of a policies kind of thing, where we define that when the auto scaling group should come into the action, it should come into action, and based upon the launch configuration, it will launch more instances in my architecture. We'll discuss that, okay? So these are the three important components of the auto scaling. Any questions so far? We haven't discussed the very fundamental concept, but still, any questions? No questions? Okay. Now, I'm going to discuss a very fundamental essence of the auto scaling. Please pay attention, because if you understand this, then you'll be able to understand the entire auto scaling. All right, so I'm just going to discuss right now. So please pay attention. I'll discuss the auto scaling basic life cycle, how exactly an auto scaling works. First thing first, you define your auto scaling group. What's an auto scaling group? An auto scaling group is a logical collection of identical EC2 instances. You group your instances together depending upon their behavior, their service and applications they are running, their functionalities. All the instances that are part of a same group have the same set of application services up and running with exactly the same configuration. So at the beginning of the stage, what you did is that you define your auto scaling group, which has just two instances. That's it. This auto scaling group contains two number of instances. That's it. Now, you have to trigger something called scale out event or scale in. Now, please pay attention. Whenever I say scale out, which means I wanna increase my number of instances. That's called the scale out. If I say scale in, which means I wanna decrease my number of instances. Scale out means increase or expand your architecture or increase in the number of instances. Scale in means shrink or decrease the number of instances. All right. So far we have an auto scaling group and we have just two instances running. These are the two instances that are up and running, and life is good. Now you have incorporated the CloudWatch alarms are a schedule-based event. For example, the CloudWatch sensed that the average CPU utilization of your architecture is above 80%. Or might be any schedule-based event. For example, during certain time of day, you want more instances. What happens is a scale out event triggers. Scale out event means that you want or your architecture now needs more number of instances, or additional or extra instances. What happens then? That it shoots up an extra instance. Now this extra instance that is launched, this one, it has exactly the same configuration that these instances contain. The same AMI, the same scripts, the same software, application, security groups, key pair, everything will be same. It's a duplicate instance. Once this extra instance is shooted up, or being created, or being launched, it is appended to your auto scaling group, and now previously you have 2, now you have 3 number of instances. So you have increased the size of your auto scaling group from 2 to 3. So this entire thing is my scale out event. Right. Now, the extra instance that I launched, I don't want it anymore, because this extra instance that I launched, I needed this instance during that time. But now, because what happens is that the instance will cost you by hourly basis, right? This instance that is being launched and it's costing you by hourly basis, you want to shut it down, because now you don't need that. What happens in the second stage is that a scale-in event triggers. What's a scale-in event? Scale-in event means that now it's time for you to decrease your number of instances inside your architecture. It can be anything. It can be a schedule-based event, or it has been triggered by the CloudWatch. Might be the CloudWatch instance that the average CPU utilization is below a certain threshold. Let us slash down the number of instances. A scale-in event should be triggered. Now, consequently, what happens next is that the extra instance is being removed from the auto scaling, which means you started from 2, then you went to 3, now you're back to 2 again. And that extra instance is being terminated. This entire thing is the scale-in. Now, this is the fundamental of the crux of your auto scaling. Any questions, any doubts? I'm just waiting, pausing for a few seconds and waiting for your questions. Just give me a few seconds over here. Okay, let's take the questions now. Okay, so Kamesh has put the question that do we need to terminate or just against be stopped? Kamesh, it will be terminated, because stopping the instance will not achieve you anything. You can't achieve any from any instance that it's stopped. It will terminate. Shiva is saying it's region specific. Of course, Shiva, this is region specific. The auto scaling works in the confinement of a region. So this is region specific. Subhash has a question. Scale out or scale in is scheduled event. What does this mean? This means, Subhash, depending upon certain schedules, you trigger these events. Let's suppose, let's take an example. You're running a website, and you have experienced that during the morning and the afternoon hours, you receive the maximum amount of traffic. So during that time, you will need more instances. But during the night time, as the night approaches after the evening, you receive very less traffic. In that case, you can trigger a scaling event and bring down your number of instances. So this is called a schedule-based event, which works on the time of day, because if your instances are running unnecessarily during the evening hours, that they will add up to your cost. Another example I can give, for example, let's suppose that you are running an e-commerce platform like Alibaba.com, Flipkart.com, anything, and you experience that during the normal days you have a normal traffic, but as the festive season approaches, like Christmas, Diwali, there's a high volume of traffic coming in because more and more users coming to a website. There's a spike in the traffic that's being experienced because more and more people are coming in and they are accessing the services on your website. So during a festive season like Christmas or Diwali, you can increase the number of instances. Once the festive season is completed or over, you can bring down the architecture back to the normal. Raj is saying, what about your data? Raj, data will be saved in your volumes, so your data will be secure. One thing we have to keep in mind, this auto scaling will never ever work on the database instances. It will only work on the backend instances, but still we can secure our data. Okay, we can retain all the data on the volume. Manjunath, your question is, so what is the time to scale out, say, a database store is 100 gigabyte? Manjunath, the auto scaling never ever works on the database servers. Okay, for the database we have a different concept called multi-AZ. We'll discuss later on. Okay. Kamesh, your question is the schedule-based event this like another jobs we configure? I'm not sure about, Kamesh, what kind of jobs we are referring to right now. But yes, the schedule-based event will trigger or will decrease the number of instances depending upon certain times of day. Yeah, you can say it's a bad job. Yeah, you're right. It's a kind of a bad job. You can say that. Any more questions before we just move further? Because I don't want to rush. It's a very important topic. Any questions you have, Karthik, Tony? Okay, it's clear. That's great. So let's move further now. So if you have understood this thing, it means that we can now move forward. Okay, let's try. All right. Now, this is quite important to know and understand that the auto scaling works in the confinement of a region upon different availability zones. Auto scaling will never spin your instance across different regions. This thing we have to understand. So an auto scaling is responsible for spanning the auto scaling group. A group contains your instances across multiple AZs in the confinement of a single region. So an auto scaling group is region specific. Instance distribution and balance across multiple zones. Now, this is also a very important concept to understand. The default behavior of the autoscaling is that it always tries to ensure that all the availability zones have equal number of instances. For example, you have the availability zone. Let's suppose that if you have the availability zone 1B and you have 1C, if you have the capacity of 4, it will always try to ensure to launch 2 instances in 1B and 2 in 1C. If you have 5, then it's quite obvious that you can't create a balance, so it will have 2 in 1 and 3 in second one. What I'm saying is that it always tries, I'm saying tries, to create a balance across all the AZs by ensuring that all the AZs contain the equal number of instances. It's a default behavior of your auto scanning. Like we have a default behavior for the load balancer. It always tries to ensure that all the instances get the equal amount of traffic. Likewise, the auto scaling ensures that all the availability zones have the equal number of instances. Okay. One second, please. Multi-zone instance counts when approaching the capacity. So you define the capacity of the instances, that okay, this is how much number of instances you want to run in your auto scaling group. As soon as the capacity gets approached, it keeps a check on that. It ensures that your capacity is not exceeded, and also it doesn't goes down. For example, let's suppose that you choose a capacity of 8 instances. It will always ensure that it will stick to 8. It will never go below that. It will never go above that. Okay. So it keeps a track on the count of the number of instances in your architecture. So this completes our theoretical overview of the auto scaling. It's time for us to move forward and start applying the auto scaling in the real-time scenario. Now you will enjoy this configuration because we will also use the concept of auto scan load balancer and see that how the load balancer and the auto scaling works hand in hand to create a fault-tolerant design. Now, so let's get on. The auto scaling can be very well tracked under the load balancer. You can see over here we have the where my cursor is on the left side in the navigation pane. The auto scaling has been structured or been divided into 2 different components: launch configuration and auto scaling groups. Let's do one thing. I think I already have a launch configuration. Let me just delete that. Okay. So our first responsibility, our first set of configuration is to define a launch configuration. What is a launch configuration? As we discussed before, a launch configuration is nothing more than just a template. It is just a template that contains your entire configuration sets or attributes. So what I'm going to do is I click on Create Launch Configuration on the top. Now, you will see exactly the same steps that I usually follow to launch an instance. But we have to keep one thing in mind. It's not an instance that I'm launching. I'm just creating a template called Launch Configuration. In this template, I need to pick the AMIs for my future instances. Now, we have to keep one thing in mind. You will use your own custom-built AMIs in the real-time scenario. You will use your own custom-built AMIs in the real-time scenario, but as of now, I'm just using the public AMIs. So I'm going with the Amazon Linux AMI. So this AMI would be the preferred AMI for all the future instances, all the instances that will launch in the near future inside my auto scaling group. I click on Select. Now I have to choose the instance type of all instances that would be launched in the future. I stick to td.micro, that it's a feature eligible instance type. I click on configure instance details. Now I have to assign a name to this launch configuration. So I'll just name it as test LG, test launch configuration, and purchasing option, I'll just uncheck this option. I'm not select anything. I'll uncheck this option, detail monitoring, because I want to stick to the standard monitoring. Now I go to advanced details, and I copy and paste the script to install my Apache PHP web application. I just copy this one and I paste it over here. All right. I will keep this option assign a public IP to every instance, because I want that each and every instance should have a public IP assigned. Right. Now I click on Add Storage. Now I will be selecting that how much root volume or additional volumes I want to define for all the instances that will be launched in the future. I set it to the default one, that's the 8 GB of root volume. Now, if I uncheck this option, delete and termination, even if this instance gets terminated automatically, now someone asks a question, what about my data? If I uncheck this option, my data will be secure. All the instances that get terminated, I will have my data secure in the form of EBS volumes. Because my volumes of 8 GB on which all the data is stored would never be deleted, even if my instance gets terminated automatically. All right. Next, I click on Configure Security Group. I will select an existing one right now, this one. Click on Review. I can review all the options and click on Create Launch Configuration at the bottom right corner. Choose a key pair and it says Create Launch Configuration. So right now, I just create a template called Launch Configuration. That's it. Now, it's time for me to apply this launch configuration to the auto scaling group. So I just go ahead and click on create an auto scaling group using this launch configuration. Now the real action begins. This launch configuration will be applied to the auto scaling group named as test ASG. That stands for auto scaling group. Test ASG, test auto scaling group. Now I have to define the group size. Group size means, now this is let's suppose I'll just put as 2. What a group size? What do you mean by the group size? Group size defines something called, I count, desired capacity. What do we mean by desired capacity? Desired capacity means that how many instances I want to be up and running at all the times. This is called the desired capacity, which means these many instances should always be there. It will never go below 2, it will never go above that, which means that this is the right capacity for my instances. This is the right capacity. I don't want to go below this one. This is right capacity or the desired capacity. So I want that these many instances should always be there to support my architecture. So right now if I've chosen 2, it will never go below 2, it will never go above that. It will stick to the desired capacity of 2 number of instances. Unless if I define the thresholds. But yes, it will always ensure that I always have at least 2 instances to support my architecture. Next, I have to choose my VPC, which means in which VPC this auto scan group will be created. So I will choose my default VPC and the associated subnets. Okay. Now we have to select the advanced details, and this is where we incorporate our elastic load balancer to work hand in hand with the auto scanning group. I click on this option called receive the traffic from the elastic load balancer and choose the load balancer that we just launched just before this topic. What I'm trying to achieve over here, I am saying that all the instances that are running, that will be running in the present, and all the instances that will be launched in the near future, all of them will receive the traffic from the load balancer automatically. Whether it's the instances that are launched in the present or they will launch in the future, all are bound to receive the traffic from the load balancer. Now let me show you how it would work. Let's suppose that this is my VPC. This is my VPC. Now, what I've done is that I created two different subnets. This is my subnet A, which is associated with my availability zone A, and this is subnet B, which is associated with my availability zone B. Now, what I will do is that I will include these two subnets to be a part of my ASG, auto scanning group. I will say both these subnets, this one and this one, they are a part of my auto scanning group. Now, what I do is I launch one instance in this one and second instance in this one. Because of the desired capacity of 2, it will create a balance, and the auto scanning group will launch one instance in one subnet, a second instance in a second subnet. Now what I will do is I will also incorporate create a load balancer on the top of it. This is my load balancer, and it will send the traffic. So this load balancer will receive the traffic from the users outside and send the traffic to my instances automatically. Right? Now, what happens is that some failure happened and this instance went down. Right? In that very case, the load balancer will automatically create a new instance. The auto scan group will automatically create a new instance because my desired capacity is 2, and now the load balancer will start sending traffic to it automatically because of the configuration. Now let's suppose that the entire availability zone goes down. Now what the auto scan group will do? It will launch a new instance in the second availability zone because my desired capacity is 2. And now the load balancer will start sending the traffic to it. What I want to highlight or show over here is that whether it's an instance failure, whether it's an availability zone failure, both the auto scanning group and the load balancer can work hand in hand to create or facilitate a highly available and fault-tolerant design. That's the reason that I am involving or incorporating the load balancer to work or in this auto scanning group configuration. Health check type, I will always choose load balancer because I want the load balancer to perform the health check. If I want to rely upon the health check of my EC2 instances to the CloudWatch, I will go with that. But in an ideal situation, if you're selecting the load balancer, you will always choose the health check to be triggered by the load balancer so that it can perform the health check for all the instances that are the part of the auto scaling group. And the auto scaling group contains both these subnets. Right. Health check grace period of 300 seconds. What do you mean by that? Health check grace period means that whenever an instance gets launched automatically, I want the load balancer to perform the health check after 300 seconds. Say, why we need the health check grace period? Let's suppose that this is your VPC, and this is an instance. It is launched in a subnet, and this is a part of an auto scaling group, ASG. Now you have a load balancer running over here, and what happens is that this load balancer is sending the traffic to it. Now some event triggered and this instance went down. Consequently, the load balancer will, what it will do? It will launch another instance automatically. Right. Now, whenever this instance right now that has launched afresh right now, do you think that just after it gets launched, it will be up and ready to receive the traffic? The answer is no. Because you might have experienced this thing, whenever you boot up your instance or launch your instance, it takes around 3 to 4 minutes for the instance to be up and running, to get 2x2 checks. Because whenever an instance gets booted up automatically, it will install all the scripts, software, applications, operating system. It will take its own sweet time. Let's suppose it will take around 3 to 4 minutes to trigger and be up and running to receive the traffic. Now, if you can recall, by default, the load balancer will send the health check message to your instances after each 30 seconds. As soon as this instance gets launched and it comes into the notice of the load balancer, after 30 seconds, it will send a health check message. Say, hey instance, are you fine? Now, this load balancer is a dumb device. It's a dumb terminal. It doesn't have any brain or intelligence. Load balancer, without even knowing that this instance has just booted up and it's not ready to accept the traffic, it will assume after 30 seconds that this instance is not responding to a health check, and it will say, hey instance, after 2 consecutive health checks you're not responding, I will not send the traffic to you. It will deny sending the traffic without even knowing that the instance is healthy, but now it is booting up. It's getting launched. Any new instance that gets launched will take its own sweet time to install the operating system, applications, services, everything to be launched automatically, to be up and running. But the load balancer, without even knowing the fact, will perform the health check after a gap of 30 seconds, and after 2 consecutive thresholds, it will say, hey instance, you're unfit, I'm not sending the traffic to you. Now this will create a confusion and chaos in your architecture. So I'm saying, hey load balancer, have some patience. Wait for 300 seconds. 300 seconds means 5 minutes. Have some patience, and whenever a newly instance gets launched, perform the health check after a gap of 5 minutes. Because within 5 minutes or after 5 minutes, your instance would be up and running. This is called the health check grace period. Because you don't want this kind of chaos or confusion to happen in your architecture. Now you can increase or decrease its value depending upon your application. Might be your applications that you are running on your instances may take longer. So you have to perform this kind of testing before, right? So you have to see that whenever your scripts or applications installed on your instance, how much time your instances take to show 2x2 checks. by default, you can stick with 300 seconds. You can increase or decrease its value depending upon your requirement. Right? Next, we have instance protection. Now, this is a new feature that they've incorporated. I'm not sure why they have included over here, which means any of the future instances will not be terminated automatically. I will not select it right now because it's not required. Any questions so far regarding this page? I'm pausing for a few seconds and waiting for the questions. I guess we have questions right now. Okay, so is saying, can you please explain the health check type once again? Okay, so I guess you're referring to the health check grace period type. Okay, I'm sorry. See, whenever you choose a load balancer, it is always advisable that you choose a health check by the load balancer, because a load balancer will perform the health check to know the instances are up and running or not. So we have seen the health check configuration in the load balancer. If I select EC2, which means I would be performing the health check based upon the stats of the instances CloudWatch alarms, instances CloudWatch configuration. Because what happens is, if you can remember, our instances are being monitored by the CloudWatch, right? For example, what's the CPU utilization and all those kind of things. So if I want to rely upon the CloudWatch metrics, I will go with the EC2. If I want to rely upon the load balancer health check, I will go with the ELB. Okay. Any more questions, guys? No questions? All right. Combination is saying which is the best one, ELB or EC2? ELB. Because if you are receiving the traffic from the ELB, it is always advisable by default choose the ELB. ELB is the best one out. All right. So now I'll just move further. Click on scaling policies. Now this is quite important. Policies means how and when model scaling group should come into action. And it should trigger the scale out or scale in event. Now please pay attention, it's quite important. If I choose this policy, keep this group as an initial size, which means it will always tick to the desired capacity of 2 number of instances. If you can recall, if I just go back, the group size is 2 instances. So if I choose the scaling policy, keep the group as its initial size, which means it will always stick to 2 number of instances. It will never go above that. It will never go below that. One of the simplest policies that you can define. The next auto-scaling policy that I can choose is called the use scaling policies to adjust the capacity of this group. What do you mean by that? This is where we go into the detailed level of configuration and define our policies. I want to adjust the capacity of the group based upon certain thresholds. So what I'm saying, I want to scale between 2 and 10 instances. These will be the minimum and the maximum size of my group, which means the minimum would be 2 instances. It should never go below that. The maximum would be 10 instances. It will never go above that. So I'm saying I would be playing around between 2 to 10 instances to adjust the capacity of my group. Right? Now, what I will do is, I will configure the scale out and scale in policies. On the top, you can see increase the group size. This section, it is for the scale out event. And down below, if I scroll down, this section is for the scaling. So I define 2 policies, scale out policy and scale in policy for this auto scaling group. These are the 2 policies that I have to define. Now what I do is I just go ahead and click on increase the group size, execute the policy when the alarm is being selected. I click on add new alarm. I will be saying that increase the group size when this alarm is being executed. So I click on create topic and I name it as ASG scale out. Now I define my email address. Right, so I define my email address, and now it's time for me to define the alarms. I'm saying if the average CPU utilization, average, minimum, maximum, some sample count, if I choose average, which means it will take the average of both instances running in my architecture, I can gauge the performance or create the alarms based upon CPU utilization, disk read operations, disk reads, disk writes, disk write operations, network in, network out. Right? So based upon what's the criteria you want to select, you can go for that. But I'll go with the CPU utilization because if there are so many requests coming in, it will increase the load on my servers, and the CPU utilization will shoot up. So if I'm saying if the average CPU utilization is more than 80%, and this happens for one consecutive period of 5 minutes, you can choose 15 minutes, 1 hour, 6 hours, or 1 minute. In that case, now you can increase it consecutive periods, for example, 2 consecutive periods, which means for next 10 minutes or 2 consecutive times, this kind of events trigger. In that case, you create the alarm. Now, over here, just click on create a simple scaling policy. And I'm saying that if this kind of event triggers, set an alarm to me. But you have to add 8 more instances in one shot. Because I have 2 instances running, if I add 8, 2 plus 8, 10, it will be maximum number of instances in my architecture. I'm saying if the average CPU utilization is above 80% for next 5 minutes, in that case, please add 8 instances in one shot. And then wait for 300 seconds by default before scaling on any other activity. This 300 seconds is called the default cooldown period. Default cooldown period. What do you mean by that? Default cooldown period means that, let's suppose that this 8 instances get launched. right? And these 8 instances will take their own sweet time to boot up. So I'm giving enough space or enough time for this instance to boot up for next 300 seconds because within 300 seconds, if the CloudWatch triggers that, okay, this thing is still going on, then it will trigger more instances and it will create a chaos or confusion in your architecture. So these newly launched instances will take their own sweet time to boot up, be up and running, ready to receive the traffic, and then I will say, okay, now we can go for another scaling activity. This is called a default cooldown period. So I'm saying as soon as the average CPU utilization of my architecture goes more than 80% for 300 seconds, add 8 instances in one shot. After that, wait for 5 minutes. As per the default cooldown period. This is called the simple scaling policy, where I am adding all the instances in one single shot without incorporating any steps. This is called the simple scaling policy. Now, we'll trigger something called step scaling policy. What is that? Over here, if you can see, it says create a scaling policy with steps. I click on this one. Create scaling policy with steps. Over here, based upon this alarm, I will not add all the instances in one shot. I will say add 2 instances if the CPU utilization is between 30 to 40%. I keep on adding the steps. Add 2 more instances if it's below between 40 to 50. Add 2 more instances if it's between 50 to 80. Add 2 more instances if it goes beyond 80%. So what I'm saying is that all these 8 instances I'm adding in steps instead of adding in one single shot. This is called the step scaling policy. And now I define the warm-up period, which means after each step there would be a gap of 5 minutes before triggering any other scaling activity. Before I want to give enough space and time to my newly launched instance to boot up, install all script and application services, and be up and running to take on the user's traffic. Is it clear so far? Now I can this is a step scaling policy, or I can create a simple scaling policy. I can add all the 8 instances in one single shot, or I can create a step scaling policy. We can just add the steps, and I can add all the 8 instances in different shots. Any questions, any doubts? Is it clear so far? Tony, your question is the CPU utilization means average CPU utilization across all instances? Yes. Average CPU utilization across all instances. Because it will gauge the performance of instances based upon the auto scaling group. An auto scaling group will contain all those instances, so it will take the average of it. Okay. Now, I'll go with the simple scaling policy. Click on simple scaling policy and add 8 instances in one single shot. Likewise, I can also decrease the group size. I create a new alarm. I'm saying I will choose the same topic. I'll create a new one. I will say AS3 scale in. I type in my email address. And I'd say now if the average CPU utilization of my instance, if my architecture goes below 30%, and that happens for one consecutive period of 5 minutes, create the alarm, and remove all the 8 instances in one single shot. I can also create the step scaling policies for the same one, but right now let's keep it simple. I'm saying remove all the 8 policies in one single shot. On the top, I'm adding 8 instances if the CPU is more than 80%. I'm removing all those 8 instances if it goes less than 80%. I'm sorry, I think I have to edit it. It was less than 30%. Right? This is how we configure our scale out and scale in policies. Any questions, any doubts? Tony, your question is, will the activities in an instance gets completed or wait for the completion before it is scaled down? Of course, Tony. Actually, the load balancer will take care of the connection training. So before the instance gets terminated, it will see for the active sessions. It should see. Kamesh, your question is, I assume the personal utilization include different zones for all instances. Kamesh, I would say that the percentage utilization, yeah, it will include all the instances in different availability zones. You're right. So, Bajit, your question is, we can add instances with any combination of count or always in the same count for scaling policy with steps. It all depends upon you. You can add 2 instances in one step, 3rd and 2nd one, 4th and 5th one, or 3rd one. It all depends upon you. Okay. There's no any protocol that we have to follow. You can add n number of instances depending upon your requirement. So I think it's clear. Now I can't simulate this kind of thing right now in the practical scenario. I'll stick to the keep the group at initial size, which means I'm saying, hey, auto scaling, I'm instructing you stick to desired capacity of 2. Never go below that, never go above that. I click on configure notifications. Now I have to add the notifications so that if any one of the event triggers, now I will select my any of the topics, and I'm saying if any one of these events trigger, whenever the instances launch, terminate, they fail to launch, or they fail to terminate, I get notifications. I can click on add notification to define more notifications for different people or different email addresses. Okay, let me just open my Gmail account. Okay, so I click on configure tags. Now this is just for the tagging. It's optional. We can skip that. Review. I click on create auto scaling group. Now this creates my auto scaling group. I click on view your auto scaling groups right now, and it has come to the action, and it has started launching my instances automatically. If I go back to my instance dashboard, you will see that it automatically triggered 2 instances automatically. And once these 2 instances be up and running, they will automatically report to my load balancer. So what I will do is let me just remove these previous instances from the load balancer because I don't need that as of now. After a few seconds, now you can see over here. You can see over here, these newly launched instances automatically they're reporting to the load balancer. Let me do one thing. Let me just name these instances. first instance, second instance. Okay. So let's wait. In the meantime, I'm just dragging and dropping the assignments for you guys to work upon this weekend, for this week. Okay. Just hang on 1 second, please. I'm just creating an assignment for you. Where is that? So this is the assignment that you have to do this week. The first assignment is for the load balancer. Let me show you that. It contains step-by-step instructions how to define and create a load balancer with the scripts. Okay, this script I have it's in a separate document. This one, right? This is for the load balancer that you have to follow, and the second document is to create an auto-scan group. It contains the step-by-step instructions, how to create a launch configuration, how to create an auto-scan group, and check the configuration and everything. And this document contains your code and scripts. This script will be used in the load balancer configuration. So this is your assignment for this week, to create your load balancer and auto scaling. And also, okay, for the CLI, I guess. All right. Okay, and over here in the slides, you already have the CLI, this one. So from here you can also practice your command line interface. Okay. So this is your assignment. In session 3 and 4, you can just see your assignments for your load balancer and auto scaling. Okay. All right. So you can see over here, you have the first instance, you have the second instance. I go to my load balancer. These two are reporting to my load balancer automatically. This first instance is showing auto service. Let me refresh the page. I think there's something wrong. Because first instance is showing auto service, so if it does that, then it will launch another instance automatically. Okay, we'll do one thing. Let's remove the load balancer. Just edit this again. Not sure why the first instance is showing out of service. Let's wait for a few seconds more. And meantime, if I just check the configuration of the auto scaling group, you can see one thing over here, that you can see the number of instances showing up over here. I'm not sure they're showing in service right now, and the above instance is showing unhealthy due to some reasons. I'm not sure why. In the activity history, you can see all the activities but pertaining to your or associated to your auto scaling group. Let's go back to my load balancer. Okay. All right. I think it has took the instance auto service because it was showing as unhealthy, and you can see. I'm not sure why the first instance is shutting down. You can see this first instance is shutting down. Something went wrong. Now, it will launch another instance automatically to cater to this loss. Now, this happened automatically. I'm not sure what triggered this thing. Now, you will see as soon as this first instance is shutting down, another instance got launched automatically through the auto scanning. Automatically. And after a few seconds, it will report to my load balancer. After a few seconds. Okay. So if I go to my auto scaling groups and check the logs, you can see over here, terminating incident instance in progress, successfully launch a new incident instance. And also, I should start receiving the notifications on my email. Let's wait. It will send me the notifications. All right. So you can see the beauty and the maturity of the auto scaling. As soon as it got to know that an instance is unhealthy, it shut it down, terminated it, and launched a new instance automatically. You can see this new instance is showing up under the load balancer. After a few seconds, if everything is fine, it will show in service. Okay. Backend saying can only see the code and scripts, cannot see assignment in Google Drive. I'm not sure. Guys, can you see, all you guys can see the assignments right now? Please confirm. Kamesh is able to say, okay. Guys, can please other guys confirm that you're able to see all the code and scripts, all the documents in section 3 and 4. Please confirm, because let me open this right now over here. Okay, they're very showing up over here. In an ideal situation, they should show up over there. You are saying, okay. So Venkat, you have to wait for a few seconds, or a few minutes. And Ramakrishna, I'm sharing the link again. Sure. Let's copy this one. You got it, Ramakrishna. You can see all the three, Venkat. Okay. And I'm just copying and pasting the link again on the chat window. Guys, just in case you're not able to access, this is a link for the Google Drive. Okay, Tony is saying you are logged in, then you can't see, but if you log out, then you can see. That's quite weird. Anyhow, I think you can see the contents now. Please practice all these things. And you can see the auto scaling, how it works. And you can see that it automatically launches the instances, and the load balancer starts sending the traffic to it. And I'll say one thing again. Okay. So this completes our auto scaling. So we'll see that as soon as it got to know that instance is unhealthy, it booted up another instance automatically to support my architecture. All right. So this completes my auto scaling. One more thing I want to emphasize over here is that okay, I think we have discussed that. For example, let's suppose that if I just click on edit over here, I can click on enable instance protection, which means any of the future instances would not be terminated automatically, or I can just go to the instances, choose one of the instance, go to actions, click on instance protection, and click on set scaling protection. If any one of the instances is a master server in the Hadoop cluster and you don't want that instance to be terminated at any cost, you can protect from scaling so that this instance never gets terminated automatically. Venkat is saying, would you cover instance cloning? Venkat, this is instance cloning only. You're automatically creating duplicate instances with the same scripts, same applications, same softwares. It's a cloning only. Okay. Some of you might be saying that it's an instance duplication. I call it as a duplication. You call it a cloning. It's the same thing. So now auto scaling automatically creates a duplicate instances based upon the launch configuration that we have defined. Azhar, you're saying, are there any log files which we can monitor to see the error messages to troubleshoot any issue? Of course, Azhar. We get the log files to the CloudWatch that we're going to discuss later on, or in the auto scaling group, we can just go to activity history and we can see the logs over here. Okay. Otherwise, we'll discuss the detailed level of log files once we discuss the CloudTrail. We'll discuss that. Okay. So I've discussed the scaling protection. So that's it. One more thing. Apart from the CPU utilization, discrete operations, network in, network out, you can also create schedule-based actions. So I can click on create schedule action. I would say Christmas Eve. I would say I need minimum 2 instances, or I would say minimum 2, 8, maximum 10. Desired capacity 8. Recurrence once. I choose 25th December as my start time, because during that time I need to increase my load. Click on create. I can create another schedule-based event. I would say end of Christmas Eve, of Christmas. Now, what I will do is I want to bring down my number of instances because the Christmas is over now. Give me 1 second. So I will say I need minimum 2 instances, maximum 5. Desired capacity is 2, and it will start at 26th December. Create. So this is how I can define my architecture based on the time of day, or it's a schedule-based events that I can trigger from here. Okay. Venkat, your question is, I want to copy one instance into another and then do the load balancing. Okay. So, Venkat, you can't copy the one instance to another automatically. It's not possible. And one thing I want to understand why we need to do that. Because if I'm saying copying one instance to another, am I referring to the copying of the data or copying of the image, copy of the settings or applications? So copying is not being supported over here. You can recreate duplicate instances using this concept. But yes, if you want to create a duplicate instance manually and then you can just include them in the load balancer, you can very well do that. Yes, Venkat, we have an option to create snapshots. We'll discuss that in our next week once we discuss the EBS volumes and snapshots. Okay. So Venkat, that thing that you're referring to, it's a separate concept. We'll discuss that. If you're saying cloning, you miss to create a duplicate instance, that we can do, but we have to cover the EBS volumes and snapshots that we'll cover tomorrow in our next week. Okay. So Subhash is saying, as you no need, as we have a template to do that. Yes, Subhash, we can use a template and we can define the snapshot ID. Now, I can't go into depth right now because that's a different concept. We'll discuss in the EBS. Yes, Venkat, image copies, snapshot, everything that can be also automated. We'll discuss the EBS volumes and snapshots, then we'll see how we can go about achieve that. Okay. Because we have to define the AMI ID, snapshot ID in that case. So what these things are all about, we'll discuss in the next week once we cover the EBS. So guys, this covers our everything. In this week, we covered a good amount of topics, including elastic IP addresses versus public IP addresses, elastic network interfaces, command interface, elastic load balancer, and the auto scaling. So these are the 5 topics that we have discussed in this week. In our next week, we'll discuss the elastic block store. Let me show you that. In our next week, we're going to discuss this thing. Volumes and snapshots, and we'll cover almost all the storage and content delivery options. Let me show you. We'll discuss all these options. I will discuss the elastic block store. So this is our agenda for next week. If the time permits, we're going to discuss like IAM and small topics. But our main focus would be on storage, content delivery, EBS volumes, and snapshots. So these are the topics we're going to discuss in our next week. Okay. Because these topics are lengthy, because storage and content delivery is quite important, and it takes some time. It's a lengthier concept. We're going to discuss it. Guys, any questions, any doubts? See, these things, storage, content delivery, database, networking will take some time. Rest, these topics on the right side, they are very small topics. So once we cover these things, this will be covered in this one class. So Subhash is saying, any assignments for this week? Subhash, I've already shared that. So I'm not sure whether you were there or not, but I already shared this thing. Let me show you that. On the Google Drive, if you just go to the this assignments folder, in session 3 and 4, I've already shared all the assignments and lab sessions and scripts for this week. Okay. All right. And guys, that's my humble request. Once the session gets over, please fill in the feedback form, because yesterday only 5 people. Just 5 people out of 15 managed to fill in the feedback form. It is quite discouraging, because I have to have some stats in my hand to show to the management of Adureka. So it's my humble request, if you have found this session quite useful, informative, so please fill in the feedback form. It is a matter of 30 seconds. You have to rate the instructor. You have to rate the content, and optionally, if you want, you can put the comments. So please, please, please fill the feedback form. Okay. So please practice, have fun, and once we discuss our topics on the coming Saturday, we'll discuss all the storage and content delivery options, including the EPS volumes and snapshots. Okay. Kamesh is saying, are we going to discuss the AMI creation sometime? Of course, Kamesh, we'll discuss that once we cover the EPS volumes and snapshots. We'll cover that. Okay. All right, guys. So thank you so much, and please fill the feedback form. I'll see you in the coming Saturday. Goodbye. Bye-bye.